In this video, we're just going to do a few practice problems for 7-4. That's arc length and surface area, surfaces of revolution. And just a couple more practice problems to get ready for the upcoming quiz. In the first one, find the length of the arc of this function, y squared equals 4 times the quantity x plus 3 quantity squared. And we want the length of that arc from 0 to 2. So the first thing we want to do here is solve for y. So we are going to square root each side. So the square root of y squared is simply y, and that's equal to the square root here. The square root of this term, 4, we can bring out. The square root of 4 is 2. And the square root of x plus 4 to the third power becomes x plus 4 to the 3/2 power. So there is our function y. And now we want to take the derivative. We're going to need the derivative y prime for the formula. So y prime is going to equal, little chain rule here, bring this down, 3/2 times 2 is 6/2, or 3 times this quantity, x plus 4 to 1 power lower, down to the 1/2 power. And the chain rule would say the inner function's derivative. The derivative of the inner function is 1, so there would be a times 1 on there, but you know it's not going to change anything, and we can drop it. So, and I'm about to erase some stuff, so let's remember we're integrating from 0 to 2 on the x-axis. So here's our derivative, and we are going to integrate from 0 to 2. And let's write out the formula. S equals, we want our integral from a to b, and then the formula says we have a radical, and under the radical is 1 plus the derivative f prime of x quantity squared dx. Alrighty, let's plug in the numbers from our problem. So we are going to integrate from 0 to 2, and then we have our radical. And under the radical is 1 plus our derivative quantity squared dx. And the derivative is 3 x plus 4 to the 1/2 power. So let's simplify under that radical as much as we can. So we're going to have 1 plus, would distribute the squared. 3 squared is 9. This quantity to the 1/2 power squared is going to be to the first power. Just plain old x plus 4. Alright, it's looking like it might not be as bad as it originally appeared, because we got some nice simplification going on under the radical. Let's distribute the 9 and collect up our like terms. So we're integrating from 0 to 2, and let's change this up to a rational exponent instead of a square root. So we're going to distribute the 9, and we're going to get a 9x plus 36, and we're going to have the 1. So 1 plus 36 is 37. 9x plus 37 to the 1/2 power dx. So it looks like we are ready to try to integrate. And it looks like we're going to need to use a u substitution. Here is our inner function. So we're going to let u equal 9x plus 37. The derivative of that would be 9 dx. So we have a dx, but we don't have the 9. We're going to need a 9 on the right of the integral sign, and to balance it, a 1/9 out front. And we're all set up to now integrate. 1/9, and let me move this over a little bit. So we're going to take our inner function, the 9x plus 37, raise this exponent by 1, now it's 3/2, and we would divide by 3/2 or multiply by the reciprocal 2/3. And we will evaluate that from 0 to 2. So let's see. 1/9 times 2/3 is 2/27. Plug in the upper limit. 9 times 2 is 18, plus 37 is 55 to the 3/2 power, minus, plug in the lower limit. 9 times 0 is 0, so we get plus 37 is 37 to the 3/2 power. And you plug that into the calculator, you're going to get about 13 0.543. And that's length. We were finding arc length. If we were to graph the original function, it's going to look a little something like this. Let's see here. It's going to look something like this. You know, not exactly a straight line, but pretty close. And we were just finding that arc length from x is 0 to x is 2. You know, there was a slight curvature to it. We couldn't just use, the distance formula or any kind of Pythagorean theorem on it. Now the next two are surface area problems. We're going to take an arc and we're going to rotate it about an axis to find a surface area. And the first one, y equals x over 2. Or you might think it's a little easier to look at that equation if I write it as 1/2 x plus 0. So what kind of function is that? It's just a linear function. So a little sketch might clear some stuff up. Let's see here. 1/2 x plus 0. That tells me we're going through the origin and our slope is a half. Up 1 over 2. And we're going from 0 to 6. So if I plug the 6 into the function, a half of 6 would be at a height of the y-axis of 3. And we're going to spin that about the x-axis. So here is our axis of rotation. When we spin that around, it's going to look like a funnel. And we'll connect back here. So we're going to find the surface area of that funnel. Back that up a little bit. So the formula here, our surface area is going to be 2 pi integral from a to b of r of x, and then we have our radical. And under the radical is 1 plus f prime of x quantity squared dx. All right. Let's start plugging in our numbers. 2 pi. We are going to integrate. We're going along the x-axis here, so we're going to go from 0 to 6, lower limit to upper limit. R of x. R of x is the distance from our axis of rotation. Our axis of rotation is the x-axis. How far away are we from it at any given x value? Well, the distance from the axis of rotation are points on the line. So r of x is going to be our function 1/2 x. The distance from the axis of rotation is dictated by the function itself. Now, underneath the radical, we're going to have 1 plus the derivative quantity squared. Well, if this is our function y equals 1/2 x, y prime is just equal to 1/2. So here we're going to have 1/2 quantity squared. So let's get rid of some of this stuff now. I need a little more room here. Get this out of the way. And we can work a little bit under that radical, and some stuff we can pull out front of that or integral sign. The 1/2 we can bring out front. Half of 2 pi is 1 pi. So now we're just going to have a pi in front of our integral symbol from 0 to 6. We're still going to have an x there. And then, well, let's leave this in radical form. 1 plus 1/2 squared. So that is 1 plus 1/2 squared is a fourth. And I can rewrite 1 as 4/4. 4/4 plus 1/4 is 5/4. And we can shorten that up. Dx. And now that's square root of 5/4. That's just a number. Let's bring it out front. So now we're going to have the square root of 5/4 times pi, definite integral from 0 to 6 x dx. Ooh, look at that. That's going to be easy to take the antiderivative of. And I can see something else we can simplify a little bit more. Break that fraction up. Square root of 5 over the square root of 4. Square root of 4 is 2. Root 5 over 2 times pi. And let's take the antiderivative. That's x to the first. The antiderivative is x squared over 2. Evaluated from, that 0 looks like a little 6 there. From 0 to 6. All right. Root 5 over 2 times pi stays. Plug in the 6. 6 squared is 36, divided by 2 is 18. And we plug in the lower limit 0. 0 divided by 2 is 0, so 18 minus 0. So what we're left with is root 5 over 2 times pi times 18 over 1. And we could reduce on the diagonal, divide out of 2. So we're going to get 9 times the root of 5 times pi. 9 pi times the root of 5. And let's even take a peek at that, what it's going to look like as just a decimal. So root of 5 times 9 times pi. 5 square rooted times 9 times 9 times pi. Times pi equals, as a decimal, 63.22. Approximately 63.22. And that would be in some kind of squared units, because we're looking at surface area. Okay, one more example here. Now we're rotating about the y-axis. And we have a downward opening parabola. Y equals 9 minus x squared is a downward opening parabola. Y-intercept of 9, x-intercept of 3, and negative 3. We are going to spin that about the y-axis. So let's write our formula. Our surface area is equal to 2 pi. Integral from a to b. R of x is our distance from the axis of rotation. And then we have our radical with under the radical 1 plus the derivative f prime of x quantity squared dx. So let's plug in our numbers. 2 pi. On the x-axis, we are integrating from 0 to 3. So lower limit 0, upper limit 3. R of x, the distance from the axis of rotation. So how far away are we from our axis of rotation? Our axis of rotation is the y-axis. And in terms of x, how far away are we from the y-axis? Well, that's just our x-coordinate. So r of x in this example is just going to be x. Remember back on this one when we had, well, I sort of pulled my picture apart. Oh, there it is. There was our line, and our axis of rotation was the x-axis. How far away were we from that axis of rotation happened to be a point on the line. So there it was just the function, 1/2 x. Here now, the distance we are from the axis of rotation is simply our x-coordinate. Easy to get that kind of backwards, so be careful. Let's see, finishing off our formula, we have our radical 1 plus the derivative quantity squared. Well, if y equals this, y prime is equal to negative 2x. So we're going to have a negative 2x quantity squared. And now let's try to simplify this a bit. We have our 2 pi, integral from 0 to 3, x out front, and let's put it in rational exponent form. So inside the radical, 1 plus negative 2x quantity squared. Negative 2x times negative 2x is positive 4x squared. Make that look a little better, 4x squared. So it looks like another u substitution. Here is our inner function. U equals 1 plus 4x squared. The derivative of that is going to be 8x dx. So we don't have 8x dx, we have x dx, so we're going to need an 8 to get our du as we need it, and to balance it, a 1/8 out front. An 8 times 2 pi is 2 pi over 8, or a quarter pi, pi over 4. And let's take the antiderivative. We're going to have our quantity, 1 plus 4x squared, to 1 power higher, to the 3/2 power, divided by the new power 3/2, or times the reciprocal, 2/3, evaluated from 0 to 3. And give myself a little more room here. All right, the pi over 4 times 2/3, we'll reduce that down, and we're going to get pi over 6. And let's evaluate the upper limit. Plug in the 3. 3 squared is 9, times 4 is 36, plus 1 is 37. 37 to the 3/2 power minus, evaluate the lower limit. Careful, we don't just plug in 0 and have everything go to 0. This term will go to 0. 4 times 0 squared is 0, plus 1 is 1. 1 to the 3/2 power, or just 1. So we're left with pi over 6 times the quantity, 37 to the 3/2 power, minus 1. And that's something to just plug into the calculator. And you're going to get approximately 117.319. I haven't solved that for myself in terms of pi. Let's check that out. So we got 37 to the 3/2 power, 37 x to y to the 3/2, that's the 1.5 power, equals, so there's our 37 to the 3/2 power, minus 1 equals, so there's our work within the brackets, and we're going to divide that by 6, divided by 6 equals, so another way to write the answer would be 37.3437, 37.3437 pi. And that would be our exact, well, we did round that off, so I guess it wouldn't be exact, it would be more approximate. And there we go.